Part 1. The Deluge that rewrote the Earth's history. Imagine a world where rain doesn't just last 4 hours or days but for 2 million years straight. This is not the plot of a science fiction novel, but a real chapter from Earth's distant past. Approximately 234 million years ago, during the late Triassic period, our planet experienced a cataclysmic event known as the Permian pluvial episode. This wasn't just a rainy spell, it was a planetary deluge that transformed ecosystems, wiped out countless species, and ultimately cleared the stage for the rise of one of Earth's most iconic groups of animals, the dinosaurs. But what could possibly cause such prolonged, relentless rain? To understand this, we must go back even further to the violent legacy of the Earth's volcanic heart. In what is now modern-day Alaska, colossal volcanic eruptions began to tear through the Earth's crust. These weren't ordinary eruptions. They were part of a massive volcanic province that spewed out oceans of lava and toxic gases. The atmosphere filled with ash, soot, and especially carbon dioxide, a greenhouse gas that traps heat. But the real disaster began when lava ignited vast underground coal beds. This combustion released even more CO and methane, intensifying the greenhouse effect. Earth's temperature soared. Surface waters of the ocean heated up to a staggering 40 Celsius 104 F, far beyond what most marine life could tolerate. With the seas warming and the atmosphere saturated with moisture, the planet entered a state of climatic imbalance. The skies, heavy with water vapor, could no longer hold their burden. Then, the rain began. And it didn't stop. For over 2 million years, rain drenched the Earth. Not just gentle showers, but torrential, acidic rainfall that leached nutrients from the soil, eroded landscapes, and devastated existing flora and fauna. The Earth was reshaped not by fire or ice but by water. This deluge, known to scientists as the Permian pluvial episode, ushered in one of the greatest mass extinctions in Earth's history. Marine ecosystems were hit hardest. Over 90% of marine species vanished. Coral reefs collapsed, shellfish disappeared, and entire chains of marine life unraveled. On land, the picture was equally grim. Up to 70% of terrestrial species were lost, including many dominant reptiles and large amphibians. Yet, in this chaos, a remarkable transformation began. When the rains finally ceased, the Earth had been reborn. The constant water influx had altered soil composition, carved new river valleys, and spurred the development of vast, lush tropical forests. These rainforests stretched nearly from pole to pole, acting as massive oxygen factories that replenished the atmosphere. In this new green world, insects exploded in size and diversity. Dragonflies the size of hawks, millipedes longer than a human leg, and amphibians as big as crocodiles roamed this revitalized landscape. But amid these giants, another group of creatures quietly emerged, small, agile, and uniquely adapted to the new environment, the early dinosaurs. Descended from archosaurs, these proto-dinosaurs were swift, warm-blooded, and upright. Unlike their cold-blooded competitors, they could survive in a wider range of environments. The extinction had removed their rivals, opening up ecological niches across the globe. Over time, these creatures diversified and grew. Some evolved long necks to graze from treetops. Others developed claws and teeth to hunt. And still others took to the air. Within a few million years, dinosaurs had spread across every continent, launching what we now recognize as the Mesozoic or Earth Age of dinosaurs. The story of the 2-million-year reign is not just about destruction. It is about renewal, resilience, and the incredible adaptability of life. It teaches us that even the darkest times in Earth's history can give rise to new beginnings. But it also serves as a warning. Today, human activity is pushing the planet into a new climatic crisis. Greenhouse gases once again fill the atmosphere. Temperatures rise. Ice melts. Sea levels climb. Scientists warn that if current trends continue, we may face climate disruptions that echo those ancient cataclysms. We must learn from Earth's deep past. The Carnian pluvial episode teaches us that climate change, when unchecked, can be devastating, but it also reminds us that life is tenacious. Our responsibility now is to ensure that we adapt wisely and act swiftly, so that we too can witness a new dawn not born of extinction, but of insight and innovation. Part 2: The Rise of the Giants. After the Great Rain ceased, the Earth entered a new phase. The skies, once filled with relentless gray clouds, slowly cleared, revealing a sun that now touched a transformed world. The once swampy plains began to dry, giving birth to vast forests and fertile basins. Life, previously devastated by the storm, now surged forth with unstoppable vigor. And within this reborn ecosystem, a new race of giants was preparing to rule: the dinosaurs. The Triassic period had ended with a devastating extinction, but this opened up opportunities. The few species that survived evolved rapidly, and among them were the archosaurs, the ancient ancestors of crocodiles, pterosaurs, and dinosaurs. Unlike the sluggish, ground-bound reptiles of the past, archosaurs were built for efficiency. They had upright postures, more advanced lungs, and faster metabolisms. These traits helped them become the dominant predators and herbivores of this new age. One of the most remarkable characteristics of the early Jurassic was the sheer size of the new creatures. In a world recovering from disaster, size was an advantage. Larger bodies could store more energy, regulate temperature better, and reach food sources others couldn't. And so, nature began to favor the massive. In the vast fern-covered plains, early sauropods, long-necked herbivores, began to appear. Creatures like Volcanodon and Tasautosaurus roamed in small herds, their long necks swinging like cranes as they stripped leaves from tall trees. These early sauropods laid the foundation for future giants such as Brachiosaurus and Apatosaurus. Their bones, now petrified in rock, tell the story of a lineage that would grow to become the largest land animals in Earth's history. Not far from the herds, predators also evolved. Theropods, bipedal meat-eaters, were gaining agility and intelligence. Species like Dilophosaurus with its distinctive head crest, hunted in packs, using speed and coordination. Their sharp claws and keen senses made them fearsome hunters. And over millions of years, some of their descendants would become even more terrifying, the Astroskelesaurus and eventually the Tyrannosaurus rex . But dinosaurs weren't the only ones to rise. The skies to saw revolution. Pterosaurs, the first vertebrates to achieve powered flight, soared above the forests. With wingspans that would one day rival fighter jets, these flying reptiles opened up a new frontier of survival. Their ability to cover vast distances gave them access to food and nesting grounds others couldn't reach. Evolution would eventually produce giants like Quetzalcoatlus, which stood as tall as a giraffe even when grounded. In the underbrush and trees, another group quietly evolved to small, warm-blooded mammals. Though still overshadowed by dinosaurs, these early mammals were survivors. They had sharp senses, fur to keep warm, and flexible diets. They thrived at night, avoiding the giant reptiles that ruled the day. They would wait for their time. Back on land, the continents were on the move. Pangaea, the ancient supercontinent, began to fracture. Massive rifts split the land, creating new oceans and separating animal populations. This geographic isolation sparked a wave of new evolution. Species diverged and adapted to new environments. Deserts formed, as did tropical rainforests. The climate remained unstable, shifting between extremes, pushing life to constantly adapt. Volcanic activity still played a significant role. Ash and gases occasionally blanketed the skies, affecting global temperatures. But unlike the catastrophic eruptions of the past, these events now acted as environmental regulators. They reminded life that Earth was still wild, still unpredictable. The rise of dinosaurs wasn't a sudden conquest, it was a slow, persistent march. Over tens of millions of years, they evolved, diversified, and spread across every corner of the globe. From icy polar forests to sweltering equatorial swamps, dinosaurs adapted to it all. Their dominance wasn't just due to strength or size, it was due to flexibility, adaptability, and the right features at the right time. As the Jurassic period matured, dinosaurs became more specialized. Stegosaurs developed armored plates and tail spikes. Ankylosaurs became walking tanks. Ceratopsians, though still rare, began to show horned features. Hadrosaurs began to evolve complex jaws for chewing tough plant material. And at the same time, feathers began to appear not just on small meat-eaters but across many species, hinting at an evolutionary path that would lead to birds. Birds, the last living dinosaurs, began their journey here, in this time of giants. Part 2 of this story is not just about dominance, it is about the rebirth of life, the power of evolution, and the beauty of Earth's ability to recover. From the ashes of extinction, life always finds a way to rise again. And this time, it rose on massive legs, with thunderous steps, under a sky ruled by wings.